All right, this is video 15C. Today we're going to understand Ohm's law and we're going to finish up with talking about circuits. So the big question for today is why were vintage Christmas tree lights such a pain in the butt? All right, so remember there are codes in the video. There are two codes, one's written, one's verbal. They are each a series of 3 numbers. You will need these in order to move on with the homework assignment. So write what is in green. You will need this for your notebook check. So this is the 15C written code. I would recommend you write this down somewhere. So what is Ohm's law, right? So we're going to do that. We're going to do the lab add to the ohm to answer that question. But Ohm's law shows how voltage, current, and resistance interact with each other. Ohm's law is an equation with the following variables. The variable V is the voltage. So voltage would be similar to the pressure. Variable I is the current. That's similar to like the actual current of water flow. And resistance, that would be similar to like the rocks in the river or in the thickness of the pipe. So you can see Ohm's law off to the right, V equals IR, and you can see that, that little graphic, I like that. Voltage is the pressure, current, or the amp is the current flowing through, and the ohm, the resistance, is like how hard it is for that current to flow through. All right, so let's just do a problem here. In an electric circuit, 9 volts is applied across a 600 ohm resistor. What is the current flowing through the resistor? So I'm looking for the current, and I know the voltage and the resistance. So I can plug that into that equation, and I solve it at 0.015 amps. All right, so then we're going to do the add to the ohm thing. We're going to talk about circuits. So circuit symbols. So 2 conditions for current to flow. There must be a difference in electrical potential. There must be conducting paths. So every part in a circuit that we're going to design is designed to meet these conditions. So the battery provides an electrical potential. A switch will provide the connect path the when they're closed, and eliminate the connecting path when it's open. Resistors will change the voltage and current. So let's look at a series circuit. It's defined as having only one path through which the current will flow. So notice, well, it's like a series. They're all connected in series. There are 3 rules that a series must follow. All components share the same current. Resistance add to equal a larger total resistance. And voltage drops to equal a larger total voltage. So what's happening here is that, well, the current is flowing through all those resistors, and at each resistor, there's going to be a voltage drop at every single one of them. All right, so let's look at a parallel circuit. So components are connected between the same electrical potential. There are 3 rules that parallel circuits follow. All components share the same voltage. Resistances diminish to equal a smaller total resistance. Branch currents add to equal a larger total current. So notice what happens to that resistance. Now, we're going to do a lab activity that shows this, but I'll give you the verbal code at this point. The verbal code is 151. I say that again, the verbal code is 151. And as always, I'll leave you with my final thought. There's too much unknown in the universe to take a break from learning. Get out there and question everything.